Hello. In this video, we are going to be finding the antiderivative of the function f of x is equal to the sine squared of x. So we're finding capital F of x, the antiderivative or indefinite integral, which is going to be equal to the indefinite integral of sine squared of x with respect to x. Notice there are no bounds because this integral is indefinite. Now then, how would we approach this? So we know about the integral of sine of x. That's pretty simple. We can just think about derivatives and how, what function we take the derivative of to get sine of x. But we're dealing with sine squared of x. And this may come up in integral calculus, though it's relatively rare. It's not something you're going to be doing every day. So to solve this problem, we're going to have to look back at the trigonometric identities. But with that, it's going to be pretty simple. So if you recall the identity that sine squared of x is equal to 1 minus cosine of 2x divided by 2, this will get a lot simpler. Now, I'm not going to derive this here. This is a trigonometric identity that you should probably remember from pre-calculus or trigonometry or however your curriculum is. But I'm going to derive this in a different video. You can look for that if this step is confusing. So let's just substitute that in. I'm going to bring back my orange. Let's just substitute that in for sine squared of x. So we have up here, we're going to have the integral of 1 minus the cosine of 2x divided by 2 dx. Now what's the first step here to simplify? And I'm going to bring it all the way over here. Well, we can bring out the 2. We can make that a coefficient on the integral, right? We can say this is 1/2 times the integral of 1 minus the cosine of 2x with respect to x times dx. All right, what's the next simplifying step? Well, we can separate this into two integrals that we're adding together. So we can make this, that's going to be equal to 1/2 times the integral of 1 with respect to x plus the integral of negative cosine of 2x with respect to x. Notice that I just separated them out. This will make doing things a little bit simpler. All right, let's just solve for the integral of 1 with respect to x. That's just going to be, bring it down here. It's going to be equal to x, right? The integral of 1 with respect to x is going to be x plus, and we're going to add the constant at the end, don't worry. Plus, well, let's actually not do a plus. Let's not do that because we can just pull this minus out, right? This minus right here. We can just pull that out and put it on the outside and bring that down here as a minus. So 1/2 times x minus the integral of cosine of 2x. And this will make things even more clear with respect to x. There we go. So how can we find the integral of cosine of 2x with respect to x? Well, we know what the integral of cosine of x is, right? That's going to be sine of x. But we have cosine of 2x. So how are we going to deal with that? Now I'm going to do this in a different color. So we know that the derivative with respect to x of sine of x, because I mean that's what you're really doing with an integral, right? You're finding what value you take the derivative of to get the function you have. So an antiderivative is what we're finding. So the derivative of that antiderivative should be the function we're dealing with, sine squared of x. So the derivative with respect to x of sine of x is going to be cosine of x. But we don't have cosine of x. How could we possibly get the 2x in there? What if we did the derivative with respect to x of sine of 2x, right? So if you remember the chain rule, we're just going to find the derivative of the function sine of x, well, sine of x or sine of u, with respect to this inner function, which is 2x. which is going to be cosine of that inner function. So that would be equal to cosine of 2x times the derivative of the inner function with respect to x. So that's going to be the derivative of 2x. So that's going to be multiplied by 2. How do we get that 2 out of there, right? Because we don't have cosine of 2x times 2. We just have cosine of 2x. What if we divided the sine of 2x? What if we said derivative with respect to x? What if we were taking this, the derivative with respect to x of sine of 2x divided by 2, right? Because then the 2 is a coefficient. The 2 stays in the derivative. It can be taken out, and it's still valid. So that would be 1/2 times the derivative that we have up here. So we could just bring this in, but multiply it by 1/2, and that's going to be, right, 1/2 times the cosine of 2x times 2. And there we go, because these 2's can cancel out, and I'm gonna actually cancel those out there. We just have cosine of 2x. So we have found the indefinite integral of cosine of 2x, because when you take the derivative of it, as we just did, we get cosine of 2x. So let's use that in our formula, and we're almost done. All right, so this is going to be equal to 1/2. That's a really weird 2 I just drew. Times x minus, what's our value here? We have sine of 2x divided by 2. And if we just multiply this out, I'm going to just bring this down here. Oh. That's going to be x over 2 minus sine of 2x divided by 4. And you can verify on your own that this is indeed the antiderivative. You can just do that by taking the derivative of this function and finding sine squared of x. And I hope you enjoyed this brief derivation. Thank you.